SwayamPrabha. Digital India. Educated India.
Welcome to lecture 37 of the course on multivariate data mining, methods and applications. The title of this lecture is Support Vector Machine for Linear Separable Classes. The objective of many machine learning tools is classification. In previous lectures, we have discussed many such machine learning tools. Now, one of the machine learning tool which can be used for classification purpose is support vector machine. One can use support vector machine when the class boundaries are linear or when you have multiple classes. Further, we can also use support vector machine when the class boundaries are nonlinear. So, in this lecture, we are going to discuss the support vector machine when the class boundaries are linear. We will also discuss the case when you have multiple classes and you have to classify an observation into one of those multiple classes. So, now we consider support vector machine or SVM. Now, this is a powerful machine learning algorithm for classification tasks, and basically what we do, we find the optimal hyperplane that separates data points of different classes in a feature space. And then this separating hyperplane actually maximizes the margin between the closest data points of different classes. And these closest data points are called the support vectors. So, basically what we do, we have the data points and then your objective is to separate the data points into different classes in a feature space, and then we focus on the support vectors which are the closest data points of different classes. And suppose we assume that the classification boundaries are linear, then we try to find the optimal hyperplane for separating the two classes, and we obtain the optimal hyperplane by maximizing the margins between the support vectors. It has several applications. Say, for example, you can apply support vector machine for handwritten digit recognition, text categorization, cancer classification using microarray data, and for protein secondary structure prediction also you can use the support vector machine. And then we can use support vector machine when the class boundaries are linear as well as nonlinear. In fact, when the class boundaries are nonlinear, we go for kernel-based support vector machine. But in this lecture, we are focusing just on the support vector machine when the class boundaries are linear. Then we can apply the support vector machine for binary classification as well as for multi-class classification. So, in the both So, in both the cases we can use support vector machine. When you have just two classes and you have to classify the observations into one of the two classes, or when you have multi-class classification or multiple classes and then you have to classify observation into one of those multi-classes. And then techniques are based upon optimization of a convex loss function under given constraints, and so are unaffected by problems of local minima. Now, here you have a set of points and you can easily observe that the set of points has two classes in the feature space, and then you have a hyperplane which divides the two classes. Now, first we consider the linear SVM. So, the learning set of the data is L equal to xi yi, I equal to 1 to n. Xi belongs to RR. So, you have R dimensional input vector, and then yi takes two possible values -1 +1. So, yi is the output variable taking these two possible values. Then the binary classification problem is to construct a function, say f, which maps from RR, which is the feature space, to R, so that Cx is equal to signature fx, and then Cx takes value 1 if say fx greater than or equal to 0 and -1 if fx is less than 0. So, this is the basic classification problem. You have to obtain or you have to construct a particular function f which helps you in classification purpose. This function f is called the separating function. And then if you have a new point x in a test set, say T, then using this separating function you can classify this new point into one of the two classes. Say we denote the two classes by pi plus and pi minus, and we classify that new observation x into pi plus if fx is greater than or equal to 0, that is y is equal to 1, and we classify x as coming from pi minus if fx is less than 0, that is y is equal to -1. Now, suppose the learning set can be separated by a hyperplane. So, your classification problem is linear or class boundaries are linear. Now, this is the hyperplane, the set of values of x such that fx is equal to beta naught plus x transpose beta equal to 0. Now, this hyperplane is called the separating hyperplane. This particular hyperplane separates the two classes. You have taken fx equal to beta naught plus x transpose beta. So, if beta naught plus x transpose beta is greater than or equal to 0, then we take y equal to 1, or we classify the observation as coming from pi plus. And when this is less than 0, we classify the observation x as coming from pi minus 1, that is y is equal to -1. So, basically the hyperplane beta naught plus x transpose beta equal to 0 separates the two classes pi plus and pi minus. So, it is separating hyperplane. This beta is the weight vector, and beta naught is called the bias term. Further, if we take b equal to minus beta naught, then b equal to minus beta naught is the threshold. You can write the separating hyperplane as x transpose beta equal to minus beta naught or equal to b. And then if x transpose beta is greater than or equal to b, we classify the observation as coming from pi plus, and if it is less than b, then we classify the observation as coming from pi minus. So, basically this b is the threshold value. Now, suppose d minus denotes the shortest distance of separating from nearest negative data points, and d plus is the shortest distance of separating from nearest positive data points. Then d equal to d minus plus d plus is the margin of separating hyperplane. And if the distance between hyperplane and its closest observation is maximized, it is called optimal separating hyperplane or maximal margin classifier. Now, we consider this figure. You have these observations and these observations. These lead points are corresponding to data points with yi equal to minus 1, say, and the blue points are corresponding to the data points with yi equal to plus 1. So, this side we have the class pi plus, and here we have the class pi minus. Then your separating hyperplane is beta naught plus x transpose beta equal to 0. So, this is your separating hyperplane, beta naught plus x transpose beta equal to 0. And the support vectors are points lying on the hyperplanes h minus and h plus. So, we consider the points which are closest to this separating hyperplane. Now, in pi minus, these are the points, and in pi plus, these are the points. So, these are the support vectors. Then, this distance is 1 upon norm of beta. Further, this distance is also 1 upon norm of beta, and the total margin is 2 upon norm of beta. Now, the question also arises, why we choose such a hyperplane which passes just in between these support vectors. Say, suppose you select some other hyperplane. Say, suppose you select this hyperplane. Then it may happen that just a slight change in this observation, or suppose there is some observation here also, then just a slight change in this observation may classify the observation into another class, or may change your result. Or suppose there is some observation, this one in this region, then just a slight change classifies the observation into this class. So, basically what we want to do, we want to maximize the margin of this supporting hyperplane from the support vectors corresponding to two classes. Now, if the learning set is linearly separable, there exists beta naught and beta such that beta naught plus xi transpose beta is greater than or equal to 1 if yi equal to plus 1, and beta naught plus xi transpose beta is less than or equal to minus 1 if yi is equal to minus 1. Now, if for some data point in L equality holds in 1, then these data vectors lie on the hyperplane, say h plus beta naught minus 1 plus xi transpose beta equal to 0. Similarly, if for some data points in L equality holds in 2, then these data vectors lie on the hyperplane h minus beta naught plus 1 plus xi transpose beta equal to 0. Now, the points in the learning set L that lie on h plus 1 and h minus 1 are called the support vectors. Now, suppose x minus 1 lie on h minus 1 and x plus 1 lie on h plus 1. Then beta naught plus x plus 1 transpose beta is equal to 1 and beta naught plus x minus 1 transpose beta is equal to minus 1. Now, if we subtract these two equations, we obtain x plus 1 transpose beta minus x minus 1 transpose beta is equal to 2. You get 2 in the right hand side. Further, if we add these two equations, then we obtain twice beta naught plus x plus 1 transpose beta plus x minus 1 transpose beta equal to 0, or we get x plus 1 transpose beta plus x minus 1 transpose beta equal to minus twice beta naught. And from here we obtain beta naught equal to minus 1 upon 2 x plus 1 transpose beta plus x minus 1 transpose beta. Then the perpendicular distance of the hyperplane beta naught plus x transpose beta equal to 0 from the points x minus 1 and x plus 1 are, say you have d minus 1 equal to, we are obtaining the perpendicular distance. So, we take mod beta naught plus x minus 1 transpose beta divided by the norm of beta, and then this is equal to 1 upon norm beta. Actually, mod beta naught plus x minus 1 transpose beta is equal to, since the point is x minus 1 and the point belongs to h minus 1. So, beta naught plus x minus 1 transpose beta is equal to minus 1 and mod value is 1. Similarly, d plus is equal to mod beta naught plus x plus 1 transpose beta, which is equal to 1 divided by norm of beta. So, we get 1 upon norm of beta. So, the margin d is equal to twice upon norm beta. Now, we can combine 1 and 2 in a single inequality as, say, yi into beta naught plus xi transpose beta greater than or equal to 1. This is your equation 1 and this is your equation 2. And if we multiply by yi, or if we multiply by yi to this equation, in both the cases we obtain yi into beta naught plus xi transpose beta greater than or equal to 1. Then the problem is to find hyperplane that maximizes the margin twice upon norm beta, subject to the constraint 3. Or equivalently, we wish to find beta naught and beta to minimize 1 upon 2 norm beta square subject to yi into beta naught plus xi transpose beta greater than or equal to 1 for I equal to 1 to n. Now, this is a convex optimization problem. You have to minimize a quadratic function 4 subject to linear inequality constraint 5. Then we use the method of Lagrange's multipliers. So, suppose we define the function f beta naught beta alpha equal to half norm beta square minus summation I equal to 1 to n alpha I into yi beta naught plus xi transpose beta minus 1. Here alpha 1, alpha 2, so on alpha n, these are n Lagrange's multipliers. Remember, we have n constraints yi into beta naught plus xi transpose beta greater than or equal to 1. Then alpha 1, alpha 2, alpha n, and then we take transpose of this. This forms a vector alpha, and norm of beta square is equal to beta transpose beta. Then to obtain Karush-Tucker conditions, what we do? We differentiate the function f with respect to beta naught and beta, and then we also differentiate it with respect to each alpha I. So, we obtain these conditions. Say when we differentiate with respect to beta naught, we obtain minus summation I equal to 1 to n alpha yi equal to 0. Further, when we differentiate the function f with respect to beta, we have this equation, we differentiate it with respect to beta. So, here you obtain twice beta and then you have half here. So, you get beta minus, then we differentiate this part. So, we actually get just this part which involves beta, and here we get summation over I alpha I yi xi. Further, we get this condition yi beta naught plus xi transpose beta minus 1 greater than or equal to 0, alpha I greater than or equal to 0, and then we have alpha I yi beta naught plus xi transpose beta minus 1 equal to 0. Then from equations 7 and 8, we obtain summation alpha I yi equal to 0, and then we also obtain beta star equal to summation over I alpha I yi xi. We just solve the equations 7. From equation 7, you obtain summation alpha I yi equal to 0, and then we also solve this equation 8, from which we obtain beta equal to summation alpha I yi xi. Then substituting 11 and 12 in equation 6, we obtain f d alpha is equal to half norm beta star square, beta star is the solution for beta, minus summation I equal to 1 to n alpha I yi beta naught star plus xi transpose beta star minus 1, where actually this f t alpha is equivalent to f beta naught star beta star alpha. And then the norm of beta star we can get from here the expression for beta star, and then the norm is equal to summation I, summation j, alpha I, alpha j, yi, yj, xi transpose xj. Basically, from here you have to obtain beta star transpose beta star, and then we already have half here, minus summation I equal to 1 to n, then corresponding to beta naught star, we have summation over I alpha I yi, which is equal to 0. Further, we get a term summation over I alpha I xi transpose beta star, and then we substitute the value of beta star from here. So, finally, we get this expression summation I summation j alpha I yi xi transpose alpha j yj xj, and the last term is summation alpha I, and these two terms are equal. Actually, you can write it as, say, alpha I, alpha j, alpha I and alpha j are scalars, further yi is also a scalar, yj, and then xi transpose xj. So, ultimately you get minus half times this term. So, we get summation alpha I minus half summation I summation j alpha I alpha j yi yj xi transpose xj, and then we can write 13 as ft alpha equal to ln transpose alpha. We are using the vector notations and matrix notations, minus 1 upon 2 alpha transpose h alpha, subject to alpha greater than or equal to 0 and alpha transpose y is equal to 0. Here, the ijth element of H is yi yj xi transpose xj. So, you are writing this term equal to hij, the ijth element of H, and ln is n cross 1 vector with all elements equal to 1. Now, suppose alpha I head is a solution for alpha I, and alpha head is equal to alpha 1 head, alpha 2 head, so on alpha n head transpose. Then we can obtain the optimal weight vector beta head as we just substitute the value of alpha I, that or we replace alpha I by alpha I head. So, you get summation over I alpha I head yi xi as the optimal weight vector. Now, if alpha I head is greater than 0, then yi beta naught star plus xi transpose beta star is equal to 1, and in that case xi is a support vector. Remember that we are using this constraint. So, if alpha I head is greater than 0, to make this term 0, we need yi beta naught star plus xi transpose beta star equal to 1. So, in that case xi is a support vector, and if alpha I head is equal to 0, then this term automatically becomes 0 and xi is not a support vector. Now, suppose SV is a set of indices for which alpha I head is greater than 0, or you can say that SV is the set of indices corresponding to the support vector. Then beta head is equal to summation I belonging to SV alpha I head yi xi. Now, this is interesting. This is the expression for beta head. But once we use the condition that if xi is not a support vector, then alpha I head becomes 0. In this summation, we only have those terms corresponding to which xi belongs to the support vector, or we have to consider only those values of I which belong to SV, that is the set of indices for which alpha I hat is greater than 0, or for which xi is a support vector. Therefore, beta hat depends upon support vector only. For all I belonging to xi is a support vector. So, for estimating beta naught, only the support vectors may be considered, and then beta naught hat is equal to 1 upon mod SV summation over I belonging to SV 1 minus yi xi transpose beta hat upon yi. Actually, this mod SV denotes the number of support vectors in L. And then the optimal hyperplane is f hat x is equal to beta naught hat plus x transpose beta hat, which is equal to beta naught hat plus summation I belonging to SV alpha I hat yi x transpose xi. So, we get this value for f hat x, and then the classification rule is Cx equal to signature f hat x. So, using this hyperplane, we can classify a new observation x also. The classification rule only depends upon the support vectors. Now, if j belongs to SV, then yj f hat xj is equal to yj beta naught hat plus summation I belonging to SV alpha I hat yi yj xj transpose xi, and this is equal to 1, or summation I belonging to SV alpha I hat yi yj xj transpose xi is equal to 1 minus yj beta naught hat. Now, for support vectors, margin equal to 1, that is yi beta naught plus xi transpose beta is equal to 1. Now, we consider norm of beta hat square, which is actually equal to beta hat transpose beta hat, and then beta hat transpose beta hat is equal to summation I belonging to SV summation j belonging to SV alpha I hat alpha j hat yi yj xi transpose xj. We simply substitute the values of beta hat here, and then we get summation over j belonging to SV alpha j hat. We take alpha j hat outside the summation over I, and then we have alpha I hat yi yj xi transpose xj, and then this is equal to summation j belonging to SV alpha j hat, and we substitute the value of this term, which is equal to 1 minus yj beta naught hat, and then we write it equal to summation j alpha j hat, because summation alpha j yj is equal to 0. So, we are using this constraint. Then the maximum margin is twice upon norm beta square, which is equal to twice summation j belonging to SV alpha j hat inverse. We just use this expression. Now, for linearly non-separable case, one can apply kernel based method. We will discuss kernel SVM in the next lecture. Further, when data set is small, linear programming or quadratic programming work well to solve the support vector machine. And for large data set, one can use a different algorithm like gradient ascent or chunking or decomposition sequential minimum optimization technique. So, one of these techniques. Anyway, I am not going into the details of all these techniques. Now, we consider multi-class SVM. So, first we consider one versus rest. Now, this approach is also known as one versus all or one versus other. And basically, the idea is to extend the binary classifier to handle multi-class classification tasks. So, your objective is multi-class classification, and then you are using the binary classifier in such a way that you can handle this multi-class classification task. Now, we consider different steps of the one versus rest classification. What we do, we divide k class problem into k binary classification subproblems of type kth class versus not kth class for all k equal to 1 to capital K. So, suppose you have taken a particular value of k, say k equal to 1, then not kth class means in that class you are taking all the observations which belong to 2, 3 or capital K. Then for all k, a classifier Fk head is constructed in which kth class is coded as positive and union of other classes is coded as negative. So, basically we have converted k class problem into 2 class problem, kth class versus not kth class. You have taken data points of kth class into one class and the data points of all other classes, all the classes other than the kth class into the other class. And then you apply to classification using SVM, and suppose this is the classifier. Then a new x is assigned to the class with the largest value of f hat kx. Then 1 versus 1. In the previous case, what we have done? We have divided the k class problem into 2 class problem. We have developed a classifier f hat k corresponding to kth class versus rest of the classes. And we do this for all the k values. And then using this approach, we classify a new observation x into one of the classes, whether it belongs to the kth class or it belongs to rest of the classes. Then we select another value of k, whether if it does not belong to the kth class, then we select another value of k, and then we check whether it belongs to that class or it does not belong to that class, and so on. Now, in 1 versus 1, instead of building k classifiers, one for each class, it builds kC2 binary classifiers. You have capital K classes, so in all you can have kC2 binary classifiers, or you can form KC2 pairs of classes. Then each classifier distinguishes between two classes at a time. And then we use a voting scheme to determine the final class level. So, in all you have KC2 classes, and then you just use a voting scheme for the new observation. You just check all the KC2 classifiers, binary classifiers, and each time you have just a pair of classes. So, you can use two class classification rule of SVM, and then finally to classify the observation you are using a voting scheme. Now, these are the steps. So, first we divide into KC2 comparisons of all pairs of classes. So, in all you have KC2 classes. Then a classifier f hat jk is constructed by coding the jth class as positive and kth class as negative for all jk equal to 1 to capital K and j is not equal to k. And then for a new x, aggregate the votes for each class and assign x to the class having the most votes. So, in this lecture we have discussed support vector machine, which is a tool for classification in machine learning. In support vector machine, basically you have to find a hyperplane which divides the two classes in best possible way. The beauty of support vector machine is that this hyperplane just depends upon the support vectors. The support vectors which are the vectors nearest to this hyperplane. Further, if you have to classify the observations into multi-classes, then we can extend the two class classification for this purpose also. One can use 1 versus 1 or 1 versus rest methods for doing the multi-class classification. Sometimes the boundaries between two classes are non-linear. So, in non-linear boundaries case, one cannot use the support vector machine which is based on linear boundaries. So, in that case one has to apply kernel trick. In the next lecture we are going to discuss this case, that is when the boundaries between two classes is non-linear, and then we will also discuss the support vector machine based on the kernel trick. I am going to stop here. Thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I'm interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP. You have your incidence of high BP, MAP, and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol, and incidence of high cholesterol. Now, before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with a 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data. So, I will be doing it according to age, by gender, and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So, what we did is, for falsification test, we took ear complaints and infectious diseases. Now, ear complaints like if you are deaf since birth, or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables. And we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a women's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now, after this, we went in for a policy implication, and in the policy implication, we tried to find two policy implications, what matters and exactly how much portion matters. So, as far as how much portion matters, we have found that on an average, 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So, an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health, on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has an impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day, but fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.
Hello and welcome to this piece of literary snippet. Today we are going to read a section from Virginia Woolf's novel Orlando, and the section that we are going to listen to today is perhaps one of the finest descriptions of the winter season in English literature. It is also a very fine piece of what we call fantasy writing. I have made a few changes to the original to adapt it for the purpose of reading. The great frost was, historians tell us, the most severe that has ever visited these islands. Birds froze in mid-air and fell like stones to the ground. At Norwich, a young countrywoman started to cross the road in her usual robust health and was seen by the onlookers to turn visibly to powder and be blown in a puff of dust over the roofs. The mortality among sheep and cattle was enormous. Corpses froze and could not be drawn from the sheets. It was no uncommon sight to come upon a whole herd of swine frozen immovable upon the road. The fields were full of shepherds, ploughmen, teams of horses, and little bird-scaring boys, all struck stark in the act of the moment. One with his hand to his nose, another with a bottle to his lips, a third with a stone raised to throw at the ravens who sat upon the hedge within a yard of him as if they were stuffed birds. The severity of the frost was so extraordinary that a kind of petrification sometimes ensued. It was commonly supposed that the great increase of rocks in some parts of Derbyshire was due to no eruption, for there was no eruptions. Rather, it was supposed that they were due to the solidification of unfortunate wayfarers who had been turned literally to stones where they stood. The church could give little help in the matter, and though some landowners had these relics blessed, the most part preferred to use them either as landmarks, scratching posts for sheep, or when the form of the stone allowed, drinking troughs for cattle, which purpose they serve admirably for the most part to this day. But while the country people suffered the extremity of want, and the trade of the country was at a standstill, London enjoyed a carnival of utmost brilliance. The new king directed that the river, which was frozen to a depth of 20 feet, should be swept, decorated, and given all the semblance of a park or pleasure ground, with arbors, mazes, alleys, drinking booths, all at his expense, of course. Frozen roses fell in showers when the Queen and her ladies walked abroad. Colored balloons hovered motionless in the air. Here and there burnt vast bonfires of cedar and oak wood, lavishly salted so that the flame were of green, orange, and purple fire. But however fiercely they burnt, the heat was not enough to melt the ice, which, though of singular transparency, was yet of the hardness of steel. So clear, indeed, was the ice that there could be seen, congealed at a depth of several feet, here a porpoise, there a flounder. Shoals of eels lay motionless in a trance, but whether their state was one of death or merely of suspended animation which the warmth would revive, puzzled the philosophers. In short, nothing could exceed the brilliancy and gaiety of the scene by day. But it was at night that the carnival was at its merriest. The nights were of perfect stillness. The moon and stars blazed with the hard fixity of diamonds, and to the fine music of flute and trumpet the courtiers danced. See you in the next episode of Literary Snippet.